Hello students, we're going to continue our talk about infinite series, and this is the second part for our introduction. In the first part, we introduced series and compared them to sequences. We also talked a little bit about the convergence or divergence of an infinite series. Well, before we talk more about how to determine if a series converges or diverges, I want to first take a little more time to get familiar with series notation. Remember, math is a language, and so this is a new symbol, so let's look at it a little more deeply. Definition: an infinite series, or simply series, is an expression of the following form. It's an infinite summation, where the summation is determined by adding up a series of terms. Each term in the series is labeled by its position. So, for example, a sub 4 is said to be the fourth term in my series. In general, a sub I is the ith term. Remember, a series goes hand in hand with the sigma notation. Sigma notation means an infinite summation, in this case, where n goes from 1 to infinity of a sub n. So based on this sigma notation, we're going to take a moment and do a quick exercise. We want to write out the first 4 terms of each of the following series. Let's start with the first expression. Let's start with the first series. This is the series n equals 1 to infinity of 1 over n times n plus 1. Now, writing out an infinite summation is very similar to writing out an infinite sequence. The big difference is, instead of commas, we have pluses in between. So we're going to list out our terms. The first term is going to be when n is 1. The second term will be when n is 2. And then n is 3. And then n is 4. It would keep going on to infinity, but we're just going to write out the first 4 terms. So when n is 1, the first term in our series is actually 1 over 1 times 1 plus 1, which is 2. Plus, because this is a summation, 1 over 2 times 2 plus 1, which is 3. 1 over 3 times 3 plus 1, which is 4. And 1 over 4 times 4 plus 1, which is 5. Again, this would continue to infinity. In other words, if I wanted to write out these first 4 terms of the series, it would be 1/2 plus 1/6 plus 1/12 plus 1/20 plus ... Cool. I bet you can do the next one. Let's take a look at example 2. The key about this example is we want to notice down the bottom that n, instead of starting at 1, is actually starting at 3. And infinite series can start at any positive integer down here, so you have to be really careful to make sure you have that right number. So we start with n being 3, and again, listing out the first 4 terms means we're going to let n equal 3, n equal 4, n equal 5, and n equal 6. And so the first term in our infinite summation is going to be 1 over 2 raised to the 3 minus 1. The second term will be 1 over 2 raised to the 4 minus 1. And the third term is going to be 1 over 2 raised to the 5 minus 1. And then the fourth term is going to be 1 over 2 raised to the 6 minus 1. Again, this is an infinite summation. But writing out those first 4 terms, we have 1 over 2 to the second, plus 1 over 2 to the third, plus 1 over 2 to the fourth, plus 1 over 2 to the fifth. This kind of might look familiar to something we did with sequences, and we actually call this type of infinite series a geometric series, but we'll look more closely at that in the next video. Let's take a look at example 3. Okay. Well, think about this one. What do we have? We want the infinite sum from n equals 1 to infinity of pi. Let's write out this series. What do you think? There's no place to put n. So what do we do, remember? All right, so we're going to list out the first four terms. N equals 1, n equals 2, n equals 3, n equals 4. But since there's no place to put n, we simply put pi as our first term, and pi as our second term, and pi as our third term, and pi as our fourth term. In fact, we are adding an infinite number of pi's together for this infinite series. And then finally, let's take a look at this last example. Again, pay attention down the bottom. Notice n equals 0 to infinity. That means the first term starts at 0, so we're going to have n equals 0, then n equals 1, then n equals 2, and then n equals 3. So if I want to list out my first four terms, they would be 1 over 2 times 0 plus 3. The next term would be 1 over 2 times 1 plus 3. The next one would be 1 over 2 times 2 plus 3. And then the last one would be 1 over 2 times 3 plus 3. This is an infinite sum, so it would continue. If I wanted to simplify those terms, I would get 1/3 plus 1/5 plus 1/7 plus 1/9. So now that we've talked a little bit about the infinite summation notation and played a little bit with different kinds of infinite series, let's talk very quickly about convergence and divergence, just in a big general sense. If you look at these four different types of series, you'll notice I'm going to put a little dividing mark right here. The top two series actually converge, whereas the bottom two series diverge. And so what does it mean if a series converges or diverges? Well, it means if a series converges, it means that if I was to add up these numbers in this pattern forever and ever and ever, so take the first, for instance, if I was to add 1/2 plus 1/6 plus 1/12 plus 1/20 forever and ever and ever, if that summation, as I went to infinity, was bounded by some number, or in other words, went to some sum, finite sum s, we would say that this series converged. And in fact, 1 over n times n plus 1 is a convergent series. Same thing applies to the second example, 1 over 2 squared, so that's 1/4 plus 1/8 plus 1/16. Again, if I was to add up these terms to infinity, that sum is bounded, and in fact that goes to a specific sum. So these two are both said to be convergent series. Now again, we're going to talk more about how we know for sure, but just kind of in the broad sense talking about what it means to converge. The bottom two, however, diverge. And do you see why the bottom two examples diverge? What happens if I add approximately 3.14 plus another 3.14, so that's already 6.28, and then I add another 3.14, that's 9 point whatever, right? So now you get my feeling? So we're adding approximately 3.14 each time, and if I keep adding 3.14 to infinity, I'm getting a really huge number. I'm actually going to go to infinity. This series does not have a finite sum, so it's said to diverge. And the last example, 1/3 plus 1/5 plus 1/7 plus 1/9, do you see that's actually just part of the harmonic series? Not all the harmonic series, but just a piece of it. So if the whole harmonic series diverges, doesn't go, well, this guy is not going to go to a sum either. So 1/3 plus 1/5 plus 1/7 plus 1/9 also diverges. Even though those terms decrease, they don't decrease to 0 fast enough. And therefore, this thing adds forever and ever and ever and will never converge to a number. So that ends our first basic discussion of series. We looked a little bit at the notation, and we talked a little bit about what it means to converge and diverge. In the next video, we get a little more detailed and talk about what's known to be a partial sum and how that affects the convergence and divergence of a series.